Thanks for joining us on a Friday morning as the conference comes to an end. Actually, so hopefully this is we got some valuable info for you in this session that you can take with you to kind of get started on a migration option here from Engine to Runtime. My name is Rex Hansen. I'm a product manager for ArcGIS Runtime.net, and I'm joined by Mike Branscombe, who's the product lead for the Runtime SDK for .net. And so we're going to, for the next hour, we're going to take you through a list of options, capabilities, workflows that should support your engine to runtime migration. But first, before we start, just want to put some things into context with regard to how we organize session tracks at this developer summit. So something that you can use or at least focus on or understand how we've put together our sessions so that you understand what we're providing, the different workflows that we promote. Obviously, Runtime is built on a common core, right? So although we deliver 6 different products, six different SDKs, they're all built on a common native core, right? And so the APIs themselves are synchronized, and the workflows in general are the same natively for all the ArcGIS Runtime SDKs. And so what we've done is we've built out a set of functional sections that apply to all the runtimes, actually. And so what you'll see here is that we've promoted those sort of overarching workflows. And the APIs that are used to promote those workflows, because they're available consistently across every runtime. So one thing to keep in mind is the functional workflows are promoted as options for being able to take advantage of runtime capabilities. Of course, we do still offer product-specific sessions that promote very specific workflows, developer workflows for those products or developer technologies they're built on. And of course, there's a set of demo theaters here to kind of show more granular code workflows or demonstrations of functionality. This factors in the sense that when Mike gets into his slides and talking about workflows that leverage runtime that follow maybe a workflow that you had or match or attempt to replace a workflow that you had in Engine, at the very end of each section he's going to talk about a set of sessions that Runtime is hosting that you can look at for more details on how to support those workflows. So after each section that he discusses. Of course, we're at the end of the Developer Summit. But all of these sessions are going to be available online for free, right? So after you get home and we start to, in the next couple of weeks, we publish these sessions, you'll be able to go watch them at no cost. So with that, I'm going to hand it off to Mike, and he can take you through the engine to runtime workflows.
Excellent. Thanks, Rex. So Rex introduced the fact that the ArcGIS Runtime is built on a common core code base, and that enables functionality across all of the ArcGIS Runtime SDKs that we support. So in that sense, the session today talking about migrating from ArcGIS Engine to ArcGIS Runtime, I'll be talking about capabilities that are available in all of the ArcGIS Runtime SDKs that are supported by the ArcGIS Runtime. What that means for you having ArcGIS Engine applications that you're migrating to the ArcGIS Runtime is it offers a broader platform support. So previously ArcGIS Engine supported or currently supports Windows and Linux. With the ArcGIS Runtime, we have a broader platform support, so still including Windows and Linux, but of a lot of interest to many people is the additional support for Android and iOS and also Mac OS as well. As I go through the session, there are some workflows that aren't available across the entire ArcGIS Runtime. So we have an additional component called the ArcGIS Runtime Local Server, and that allows you to support some of those engine-based workflows that you're not able to fully migrate to some of the new data formats or workflows that we support within the ArcGIS Runtime. So I'll talk specifically in some cases about the ArcGIS Runtime Local Server as providing some additional capabilities to you in your migration. One thing to say about that is it's only available on Windows and Linux. So it's available within the ArcGIS Runtime SDKs for .NET, Qt, and Java on Windows and Linux. But for the majority of the session, like I said, I'll be focusing on workflows and functionality that's available across the ArcGIS Runtime. So one thing to say is that last year we ran a session like this, migrating from ArcGIS Engine to ArcGIS Runtime, and there were still quite a lot of functionality gaps that people saw as preventing them being able to migrate. This slide lists all of the functionality that we added to the ArcGIS Runtime in the last year and early in 2018 as well. And that really filled out many of those gaps, and there's really just a few remaining features, such as perhaps support for the utility network that might be a consideration in your migration. But otherwise, particularly for data format support, many of those data formats and layer types have been brought over. The interesting thing is this slide also lists functionality that was not previously available in ArcGIS Engine. So things like being able to run very high performance line of sight and view shed on a GPU, on the GPU of the device, performing visual exploratory analysis. That capability was never previously available in Engine. So there's a lot of new capabilities in the ArcGIS Runtime that you can take advantage of when you move over. So in thinking about the session and migrating from ArcGIS Engine to ArcGIS Runtime, really identified 5 major areas of functionality that I want to look at in terms of migration. So maps and data, workflows, editing workflows, 3D analysis, and then routing and geocoding. And we'll go into each one of those in detail to talk about the considerations for the content types and the workflows and how they migrate to the ArcGIS Runtime. So one thing to say is actually this session is very much focused on that cross runtime support. So I'm not really going into any details about kind of application logic or UI behavior that might be specific to any of the individual APIs or SDKs up there. So there's obviously consideration in terms of UI components and that kind of thing that we won't have time to address in this session, but are obviously relevant to your migration as well. So first up, let's take a look at maps and data. So when you're working with ArcGIS Engine, the maps and data document types and workflows are the ArcMap document, the MXD. You may have had map packages, MPK files that bundle up the content within your map document and contain that data, layer files and layer packages as well. So those are document types and formats that you had available within ArcGIS Engine. Let's take a look at the equivalents within the ArcGIS Runtime. So I've broken these down into moving from ArcMap documents and map packages to online maps and mobile maps, and I'll cover each one of those in a bit more detail. So online maps are maps from ArcGIS portals. They are read and write in ArcGIS Online, ArcGIS Pro, and ArcGIS Runtime. So these online maps are essentially based on the web map spec. So we're talking about web maps that contain online layers and also embedded content. So it's essentially a JSON definition. You can see an example there on the right-hand side that contains references to online layers that might be feature layers in your portal or on your server, map image layers, tiled layers, or vector tiled layers. There's also a type of embedded content that we can put inside web maps or reference from web maps, which are feature collections, and that's just a simple JSON representation of features and their geometry and attributes and rendering information as well. So it's essentially like almost like the contents of a feature layer that's just contained within JSON within your web map. Web maps also contain some app configuration properties that you can define as well, and you can use these to identify within your application whether you want to enable or disable specific areas of functionality such as search, measure, routing, location. So those are online maps. I said they're in Portal, read and write within Online, Pro, and the Runtime. The other map type that I mentioned is mobile maps. So these are maps from ArcGIS Online and ArcGIS Pro based on the mobile map package, so the MMPK file extension. It's essentially based on the web map spec, so it's like an extension of the web map spec that supports content within that mobile map package instead of referencing online layers. The mobile map package includes the layers and the data, so it includes feature layers and the tables, all of the geometry and attributes that were referenced. It can include raster datasets. It can also include tile layers as a TPK, so they're traditional raster tiled layer, but it could also include vector tiled layers as well. So if you're generating a mobile map package from ArcGIS Online, you've heard a lot this week actually about on-demand workflows and pre-planned workflows, probably from taking these maps offline from your portal. So there's a couple of different workflow options. You can also create those mobile map packages with ArcGIS Pro. And if you're creating them Pro, we actually have the option to include the geocoding and routing capabilities inside that mobile map package. Otherwise, if you're working with a mobile map package that you've taken offline from ArcGIS Online, then you need to look at other ways of provisioning those geocoding and routing data sets onto the device, such as sideloading them or perhaps host them as portal items, and then downloading those portal items as part of your logic to go offline. Okay, so that was a quick look at the map formats. What about the data formats then? So these are, on the slide here is the data formats that you have available with ArcGIS Engine, so different geodatabase types, and then other data formats such as shapefile, raster datasets, different service types, and then some of the open specs and TIN and CAD data as well. So we'll take a look at how that translates to the ArcGIS Runtime then. We've still got support for shapefiles. One of the things that I'll be talking a lot about is the new mobile geodatabase with the runtime. And that's essentially the geodatabase that's inside one of those mobile map packages that I was talking about on an earlier slide. We have support for raster data as well, so a number of different raster data formats are supported for direct read. And of course we support the feature service and map service and image services from ArcGIS Enterprise, and then also those OGC specs as well, the WMS, WMTS, and we have WFS on the roadmap. So I'll drill into each one of those in a bit more detail then. The mobile geodatabase is a .geodatabase file extension. It's based on SQLite, which means it's cross-platform, it's portable, and it's efficient. So that's how we're able to support this mobile geodatabase across Windows, Linux, Android, iOS, and macOS. It contains the schema and the data, but different to previous geodatabases that you might be familiar with, it also contains all the rendering information for the layers as well. You can create those mobile geodatabases from ArcGIS Online with either the on-demand or the pre-planned workflow for taking maps offline. And in that case, you'll get a mobile map package that references a sync-enabled feature service, and the mobile map package contains a mobile geodatabase that you can make edits to, and then you can synchronize back with your service. There are a number of different parameters and options when you actually take this data offline from a service. So I've talked about synchronization there, but you can use a download-only mechanism, and there's a number of different options in there. You can also generate these mobile geodatabases directly from a feature service, and that's actually what's happening internally when you take a map offline. So if you publish a feature service that is synchronization enabled, you can request a mobile geodatabase from that, download that mobile geodatabase. Perhaps if it's a download-only mode, it's just essentially a reference layer within your application. You can obviously interact with that and query it. If you want to edit that data and push that back to the service, then it needs to have come from a synchronization-enabled feature service, and then you can synchronize both bringing down changes and also pushing those changes back up. And then if you create a mobile map package with ArcGIS Pro, that will contain a mobile geodatabase for any of the feature data that you had in that map. And in that case, from ArcGIS Pro, it's currently read-only. And there's a link on the bottom right-hand corner there, esriurl.com/create offline map. And that's an excellent guide topic within our documentation that discusses all of the considerations about working with offline maps in the ArcGIS Runtime. So what about raster data then? Well, ArcGIS Runtime supports direct read of lots of raster data types. Interestingly, you can also apply a number of different renderers to the raster data sets via the API, so that I've listed them there: blend, color map, hillshade, RGB, and stretch renderer. You can also apply raster functions on the fly. So these are things like masking, clip, pan sharpen, or raster calculator, and you can apply those both to raster layers in the runtime that are referencing image services hosted by ArcGIS Server, or on local raster data sets referenced by a raster layer in the API. There's a type within the mobile geodatabase called a mosaic dataset, and that's essentially a way to store and manage a number of raster files as a catalog. It's a data model that's implemented inside that geodatabase. You can create those in in various parts of ArcGIS, but you can also create them within the Runtime API. So if you haven't created it within Pro in advance, you can use the ArcGIS Runtime API to reference a collection of raster data, create a mosaic data set inside the mobile geodatabase and view that inside the API. So feature services. Feature services are hosted on ArcGIS Enterprise or ArcGIS Online. They allow you to display, query, and edit that data, and that data is residing in some kind of geodatabase behind that service, whether it's an enterprise relational database or the data store, or it's hosted in online somewhere. And the ArcGIS Runtime API allows you to make REST, essentially behind the scenes, it's making REST calls to the API that's exposed by that feature service. As well as display, query, and edit of that data, you can create these mobile geodatabases, download them, and synchronize. One thing to note is that it supports simple feature access, so we don't include things like a geometric network or a topology inside that database. So what about map and image services then? Well, map services are hosted by ArcGIS Enterprise or ArcGIS Online, and they dynamically render map images on a per request basis to the client. So as the user pans and zooms, it's dynamically rendering those map images. They're based on pre-configured layers, so you publish a map as a map service, and that includes all of the layers and the rendering information. You can override those via the dynamic layer capability. So there's an endpoint of the API exposed by the server called dynamic layer, and that allows you to actually connect to that service and entirely change the definition of that service, and that's supported within the API. We also support image services, so they're exposed through the API as an image service type and then as a raster layer within the Runtime API, and that allows you to dynamically access raster imagery and then apply those rendering rules and raster functions that I talked about on an earlier slide. So that was an overview of the data formats and the migration routes for migrating your data formats and document formats to the ArcGIS Runtime. What about some of the additional formats that aren't supported with the ArcGIS Runtime that you still have large workflows based on with your engine implementations today? And that's where I said the ArcGIS Runtime local server component can help provide additional support for those if you're building applications for Windows and Linux. So here I'm talking about things like existing ArcMap documents, map packages as the MPK format, layer files, layer packages, and also the file geodatabase, so feature classes, raster datasets, mosaic datasets in that file geodatabase. And the ArcGIS Runtime local server component provides a local geoprocessing service and also a local map service. And the best way to think about these is essentially like a mini ArcGIS server, so it's service types exposed locally on the machine that you as a developer via the ArcGIS Runtime API control those services. So the MXD, MPK, layer file, layer package, they're supported with that Runtime local server. It's available on Windows and Linux desktops with the .NET SDK, the WPF API, the Java SDK, and also the Qt SDK as well in C++. And the local server allows you to read map packages and create local map services, so that's rendering maps based on the content of that map package. It also allows you to actually read and manipulate that content via local geoprocessing services. So local geoprocessing services created from a geoprocessing package, and that's something that you create currently within ArcMap 10.5.1. And those packages contain custom geoprocessing tools that you've created with Model Builder or Python. So there's a diagram at the bottom there. You're working within the desktop environment, authoring a custom geoprocessing model in Model Builder or Python. You publish that as a geoprocessing package, reference that with the ArcGIS Runtime local server, create a local geoprocessing service. That exposes a REST-based API that is accessed via the ArcGIS Runtime API on Windows and Linux to the .NET, Java or Qt SDKs. So remember, this workflow is all about supporting some of those additional content types that you're not quite ready to move over to the equivalent with ArcGIS Runtime, where you've still got workflows that you need to support. So we'll take a look at a demo of how that works with the ArcGIS Runtime local server. The scenario here is that we've got a map and data viewer, so I just need to allow the user to browse for map packages that have been shared from ArcMap. I want to perhaps replace the current map with that map package. But then also I want to allow the user to browse for a file geodatabase on disk, view the list of contents inside that file geodatabase, choose an item and then add it to the map. So let's take a look at that application. It's a WPF application that I've written with the ArcGIS Runtime SDK for .NET. And I'll browse here for a map package. And in the workflow that I've implemented here, every time I open a new map package, it will actually replace the current map and then display the new mobile map package. Display the new map package. So what's happening in the background is it's just passing that map package to the local server, creating a local map service, and then rendering that in the client. The second part of the demo here is actually browsing for a file geodatabase on disk. So if I browse through the file system here, I've got a folder of SRTM data, and if I choose that, that will actually display a list of the contents of that and the type. So I can see here I've got an SRTM data set within that file geodatabase, and it's a mosaic type. And if I load that selected data set, what that's actually doing is creating a new map service, creating a new local map service, and actually injecting that raster mosaic into that local map service. And you can see as a user, I don't know anything about what's going on behind the scenes there. I'm just browsing for this content that I might have had from those engine workflows and then adding that to my runtime application. So let's take a look at how this was implemented then. So I've got here Visual Studio. This is the solution for that application. The first part was just simply browsing for an MPK. So there's nothing particularly complicated in there. I display an open file dialog with the MPK file format, and then just set the selected path to the map package. Then I click that button to actually load the map package, and that called my method here to load the map package. So let's take a look and see what happened in there. So it created that local map service based on the path that was provided, started the local map service, created a new map image layer based on that local map service URL, and then replaced the map and added that map image layer to the collection of operational layers collection of the map. So that was the first part. That was actually very straightforward. The second part required me to write a little bit more implementation to actually allow browsing for the file geodatabase. But when you see this, you'll realize the enormous amount of flexibility that the ArcGIS Runtime local server and Python scripts provide to you. So in order to browse for my file geodatabase and iterate the contents of that, I wrote a Python script. So it takes an input parameter, which is just the workspace. So that's in my open folder dialog there, I browsed for a geodatabase, and that was the workspace that comes in. I then create an in-memory table, add a couple of fields to that for the name of the data set and the data type, get an insert cursor onto that in-memory table, and then really it's just a case of using ArcPy to iterate the contents of the different layer types in there. So I run a few queries to just get back the different layers of data type, feature classes, mosaics, raster data sets, raster catalogs, and finally just pass that table back. So once I'd written my Python script, I'm showing it to you here in Notepad. Typically, I would typically use Visual Studio to write those Python scripts. It provides a good debugging environment, and you can have that run against the Python environment that's installed with ArcMap. So having written the Python script, the second stage was to create a toolbox and add that Python script to the toolbox. You can see here that ArcMap auto-generates a UI within this environment based on the input parameter, and that's just the workspace. And I've got an example workspace here that I can drag on. So I'm running the Python script with an ArcMap, and essentially what that's doing is allowing me to validate the inputs, the processing, and the output for this. And we can see in the result window over here that we've got a successful execution of that if I look at the messages, we can see that it succeeded. So that's, once you've got a valid, successful model, you can then share that result as a geoprocessing package. If we just take a quick look at the in-memory contents here, we can see that actually that geodatabase that I dragged on had 4 different types of content, and it's returned the name and the data type there. And then, like I said, once you've got a successful execution of the model and you've got a result, then you just share that as a geoprocessing package, and then it's just a case of starting up a local geoprocessing service in the application to reference that geoprocessing package. So we can see here I'm creating a local geoprocessing service, referencing that package. I start that, and then I create a geoprocessing task, and then later on I can call into that, providing the location for the user that the user browsed to. And within that Python script, I was using the ArcPy library, so there's a number of different libraries and functions in there. There's the ArcPy data access and ArcPy mapping, so there's an enormous amount of flexibility and extensibility points in there within Python. Okay, so part 1 was browsing for a map package, just a simple file browser, and then creating a local map service for that MPK file. Part 2 was browsing for the file geodatabase, viewing the contents and the data type, choosing an item and adding that as a layer to the map. One thing to say is the approach depends on the content, actually. So feature classes, raster datasets, and mosaic datasets can be added to a local map service as a dynamic layer. And then there are some types of content where you need to maybe have a little bit of additional implementation, such as a raster catalog that's not supported by that dynamic layer capability. I've actually got an extra Python script just to bundle that up, so we can see an additional Python script here that's going to take a file geodatabase, the name of a raster, and then an output folder. So what it does is gets a reference to the location that the tool is running from. It builds up the source or builds up the path for an empty map document, and then copies that map document to a new location using the copy management tool of ArcPy. We get a reference to the map document. We create a new raster catalog layer. So this is the workflow that's specifically for raster catalogs. And then saves that layer to a file, gets a reference to that layer instance, insert that into the data frame within my map document, and then save my map document. So that's just about taking an empty map document, creating a raster catalog layer, and injecting it into the map document. And then finally just packaging up that map. So the ArcGIS Runtime can actually create map packages as well as consuming the map packages. So that provides some additional interesting workflows as you bring those engine workflows over to the ArcGIS Runtime. Okay, and then I've got another demonstration here of again using the ArcGIS Runtime local server to take some of those same concepts and apply those in a slightly different workflow. So the scenario here is I want to browse for a file geodatabase containing some raster data, choose that raster data set, add that to the view, and then actually run a view shed on that selected raster data set. So let's take a look at that in action. So when I first launched the application, what it's doing is I've got an initialize utility that's just starting up the local service and allows me to browse for the file geodatabase. So I'm actually going to browse for the same SRTM data that I showed in the previous example there. So we can see the workspace, and then it's found the SRTM dataset. I'm just populating a combo box there. I've added it to my table of contents over here, and it's been rendered with some opacity. And then the second part of this demonstration, I said I want to actually use that same raster dataset to run a viewshed. So if I click on my Run Viewshed button and just select a location on the map, it's added a point, and that's now passed that point off to a local geoprocessing service that's going to run a viewshed operation based on the input. And we can see that that's a 10-kilometer viewshed around that location. So again, I'm building on some of these same concepts. I'm reusing that list geodatabase concept, list geodatabase contents GPK and Python script that I created in the first demo. I'm just reusing that as part of this workflow. But then in the second part, I pass that raster dataset that I referenced straight to the geoprocessing service that's going to perform the viewshed. And we've been talking about, in a number of ArcGIS Runtime sessions so far, we've been talking about the new viewshed capabilities that are in the ArcGIS Runtime introduced at version 100.2. And those differ from this workflow. So the exploratory visual analysis of the new viewshed and line of sight, very high performance visual exploratory analysis, you don't get any access to the results of that viewshed or the line of sight. In this workflow, you don't get quite the same performance level, but I do have full access to the results of that data, and it's running against the full resolution of the data in the dataset rather than just what's available in the view at the time. Okay, so again, that second demonstration of using the local server there, you reused that list geodatabase contents Python script, took in the path to the geodatabase, provided me a table of contents with the name and the data type. I again used a local dynamic map service with an empty map document, created a local map service from that map package, and then created a map image layer to visualize that raster dataset within the view. And the reason for that workflow is because it was in a file geodatabase. It wasn't just a raster dataset directly on disk or within a mobile geodatabase that I could just access directly within the runtime. And then the third part was running a viewshed. So that was a custom Python script, took in the path to the file geodatabase, the raster name, and then some other inputs about the observer point feature and the viewshed distance and height, and ran that and then rendered the results back as a map service within the view. Okay, let's talk about in each section as I go through these. So we've just got to the end of the maps and data section. I've got a roadmap. This roadmap isn't necessarily for any specific release. These are the things that we're looking at to enable additional workflows. So there's a roadmap for the maps and data within ArcGIS Runtime. We're looking at allowing you to create and save those mobile maps. At the moment, I said if you create one from ArcGIS Pro, then it's read-only. You can create one from ArcGIS Online and synchronize it, but at the moment, the API doesn't allow you to just create and save those mobile maps. So that's a workflow that we're looking at. As you build applications that connect to your portal and download mobile maps, perhaps for a number of pre-planned areas that your administrator has created for you, you can sense that you might have downloaded multiple maps and you need to manage those in some way. So we're looking at how you might manage those local mobile map packages. We're also looking at providing a way via the API to create a mobile geodatabase on disk. So currently, to create an editable mobile geodatabase, it has to come from a feature service, either as part of an offline map or as part of just a direct call to create a sync-enabled geodatabase from a feature service. We're looking at extending the API to allow you to just create a mobile geodatabase on disk from scratch. And then also, probably a little bit further into the future, is support for the utility networks that you've been hearing a lot about. And that might be I anticipate that will probably be a multi-phased approach, because there's connecting to utility networks in a connected fashion and executing queries against the service, but there's also being able to take content from a utility network offline, analyze that, make edits to that, and then synchronize. So that's all on the roadmap, and we'll see that in multiple releases in the future. And then, as Rex mentioned, we're at the end of the week in this session, but here's a series of sessions that I would recommend as that you go back and look at the proceedings and the videos that are available to you afterwards as a series of cross-runtime sessions all about maps and data within the ArcGIS Runtime. Okay, so let's take a look at editing then. So in ArcGIS Engine, the workflows for editing mirrored the workflow within ArcMap. The editable data formats were those geodatabase formats and shapefiles. The editable content that you had within Engine was simple features and feature classes, but also complex features, geometric networks and topologies, and of course geodatabase schemas too. And the workflow was centered around an edit session, an edit operations, and for offline editing within ArcGIS Engine, at least offline editing that required synchronization, to use that geodatabase replication. So let's see how that editing workflows in Engine migrate over to the ArcGIS Runtime then. So the editable content within the ArcGIS Runtime is of course feature services that are hosted in your enterprise GIS server or ArcGIS Online. Mobile map packages can contain editable content. Mobile geodatabases are editable if they've come from a sync-enabled feature service. That mobile map package actually contains those mobile geodatabases. Feature collections are editable, so those embedded content types that I said are in portal items or web maps, you can edit those feature collections, and then shapefiles as well. So let's take a look at some of those editable content types in a bit more detail in the runtime. So the feature service, ArcGIS Enterprise or Online, it can create that mobile map package from a sync-enabled. If you're creating a mobile map package from a web map, it will reference all of the sync-enabled feature services in that map and generate mobile geodatabase with the editable content from that. So you use within the API the offline map sync task to run that workflow. You can create a mobile geodatabase directly from a feature service, from a sync-enabled feature service, and there's a geodatabase sync task within the API to allow you to do that. It's also the feature collections, which is that static content within the web map or the portal item. So the editable content within the runtime right now is essentially simple feature editing. So the mobile geodatabase doesn't contain topologies, utility networks, or transportation networks that you can edit, but it does contain point line, polygon, multi-point geometry types, feature classes. You can edit and synchronize the features, the attributes, and any attachments that you make on those features. So the workflow then for editing within the ArcGIS Runtime, you create or you get a feature from a table instance, and we have a number of different table types within the API. So there's a geodatabase feature table or a shapefile feature table. So you create or get a feature from the table. You can modify the geometry, the attributes, and the attachments. You apply those edits to the table via methods add, update, delete. And then an important thing to note is that depending on where that content's come from, there's probably an additional method call. So if you're editing a service, you need to make the apply edits call to push those edits back up to the service. That allows you to control when those service calls are made. If you're editing content that's in a mobile geodatabase that's been taken offline, you need to synchronize that either with the geodatabase sync task if you're working with a mobile geodatabase at the granular level, or if you're working with an offline map, you call the offline map sync task, and that will synchronize all the geodatabases within that mobile map package. Or if you're editing one of those feature collections, you need to actually either save the web map or save the portal item that references that feature collection. So the roadmap for editing within the ArcGIS Runtime then, we're looking at allowing you to edit the contents of mobile map packages that came from Pro and then share those back with Pro and integrate those edits back into your Pro workflows. Currently, the mobile map package is read-only if it's created with ArcGIS Pro. We look on the roadmap for the runtime is KML, and we're looking at allowing read and write of KML. And also another workflow that we're considering is being able to apply edits at the root level of a feature server. And one of the capabilities that allows is actually if any of those edits fail on a specific layer, to roll back all of the edits that were applied in that transaction. Okay, and again, some recommended sessions, just for reference, when you look at the slides, these are cross-runtime sessions. There was a couple of excellent sessions on working with maps online and offline, and also editing your data online and offline. In fact, there's a repeat of the online and offline maps this afternoon at 1 o'clock. Okay, so we've taken a look at maps and data, we've looked at editing. What about 3D content? So within ArcGIS Engine, the 3D content that you had was based on the ArcGlobe document or ArcScene document. Those had corresponding applications, ArcGlobe and ArcScene. 3D content, such as buildings, are represented as multi-patch feature classes. And then within the ArcGIS Engine API, there was corresponding controls that represented those document types and applications, so the globe control and scene control. Within the ArcGIS Runtime, 3D content is provided to you as scene service layers. If you're working in a connected online environment, those are published using ArcGIS Pro to ArcGIS Online or ArcGIS Enterprise. You can also create scene layer packages, so that allows you to take that 3D content offline and use that within the runtime. Elevation content is provided as services or local raster datasets, and also you can perform exploratory visual analysis within the 3D environment with the ArcGIS Runtime, so very fast visual analysis, the view shed and the line of sight. And that's based on what's rendered in the scene view at the current time. So the roadmap for 3D in the ArcGIS Runtime then, we're looking at allowing you to read and write web scenes, location display on the scene view, support for vector tiled layers in the scene view. So currently vector tile layers are supported in the 2D map view only. We're looking at more exploratory visual analysis tools, providing a sketch editor on the scene view, and also local scenes as well, so something more equivalent to the ArcScene and the scene control that was available for Engine. So again, for 3D then, some sessions that I'd recommend looking up afterwards. Okay, moving through from maps and data right through, now we're on to analysis. So analysis within ArcGIS Engine then was essentially based on, if you're working at the granular geometry level, it was based on topological relationships. So the geometry objects, point, line, polygon. They implemented interfaces, iProximity operator, iTopological operator, and that allowed you to perform some of those kind of low-level geometry-based analysis. You could also do analysis of layers using geoprocessing, and then there are extensions for specific types of analysis as well. And in many ways, actually, the runtime is similar. We no longer expose those interfaces on geometries. Obviously, we have a geometry engine, and that's a very fast, high-performance geometry engine that exposes a number of different methods. So you pass in geometries to make a comparison, such as intersects or buffer a geometry, or identifying whether they overlap. And it's, in that sense, it's not bound to any data or services. It just operates on it's stateless and operates on the data that you provide. It's very efficient. And then it's also, you use that in a lot of different workflows. So if you're doing a geoprocessing workflows, it's very common still to make use of the geometry engine for buffering a geometry or for reproducing a geometry, perhaps. The ArcGIS Runtime still supports geoprocessing. And actually, we saw how on Windows and Linux with the .NET, Java, and Qt SDKs, you can run that in an offline environment using the local server. You can also run geoprocessing services that have been published to ArcGIS Enterprise. And then ArcGIS Online actually hosts analysis services that have been published by Esri. And then the additional functionality for analysis provided with the ArcGIS Runtime is that high-performance visualization, the exploratory analysis tools, the view shed and line of sight in the scene view. But also, in terms of visualization, we support new renderer types as well. So the smart mapping renderers that are available to you within ArcGIS Online, if they're within your web maps, you'll be able to visualize that within the ArcGIS Runtime. Okay, so the roadmap for analysis within the ArcGIS Runtime then, we're looking at adding additional geoprocessing tools. And one thing we really want to hear from you is feedback on if you need additional geoprocessing tools that currently aren't supported. So within the guide documentation on our developers site, we have a reference document that lists all of the currently supported geoprocessing tools. And there's about 300 of the 1,200 or so tools that are supported across ArcGIS. We've chosen that 300 or so based on our initial analysis of the most common tools that will be required. But we've also been taking feedback from you over the last 2 or 3 years on the tools that you need, and we've been adding those. So we really want to hear that feedback on tools that you need to enable those workflows. We're also looking at support for ArcGIS Pro geoprocessing packages and map packages within the local server. Currently, that local server component requires packages created with ArcMap 10.5.1, and then more 3D exploratory visual analysis tools as well. So here are some recommended DevSummit sessions again. All of those are passed at this point, but this is a reference for you to go back and then look up these sessions. And the final part of the 5 areas we identified, routing and geocoding. So within ArcGIS Engine then, your routing and geocoding routing was based on ArcGIS network datasets, required a network and analyst extension. You executed that via ArcObjects or geoprocessing. You could also connect to and use ArcGIS Server Network Analyst services. And then geocoding was based on those ArcGIS locators. So in terms of migrating your routing and geocoding functionality to the ArcGIS Runtime, well, the content types are essentially the same. Routing is still based on ArcGIS network datasets. There are specific optimized network analysis service types that you connect to and use within the API. So within the runtime APIs, there is a route task, closed sys facility task, and a service area task. And they can connect to the online services hosted in ArcGIS Enterprise or ArcGIS Online and execute those optimized network analysis services. The ArcGIS Runtime also provides a local equivalent of those as well. So if you take a network data set offline, you can run the route task, service area task, or closest facility task against those network data sets in a disconnected environment. That content type is either packaged into a mobile map package with ArcGIS Pro, or you could create that and wrap it up as an item and download it from the portal. So there's maybe a few different workflows for provisioning it to the device. And then geocoding, essentially similar idea. It's reusing the ArcGIS locators that you already have. They can be published as a geocode server endpoint, obviously, so we can support geocoding against services, but also they can be packaged into mobile map packages with ArcGIS Pro to use in an offline disconnected environment. So what's the roadmap for routing and geocoding in ArcGIS Runtime then? Being able to take locators and networks offline from a web map. That's currently those service types, geocode services and network services, don't support any way to extract a portion of data from those services. But what we're looking at is a way where when you open up a web map and they reference geocoding and networking services, that we're able to reference other items, so switch those to other items that can be downloaded with that web map into an offline map. And also additional network solvers as well, such as perhaps the multi-vehicle routing problem. And again, for network analysis and geocoding, some recommended sessions there. All right, Rex, I'll hand back to you.
Great, thanks, Mike. I like to say content rich, lots of information, right there. Some great information to start with to get you going, moving from engine to runtime. Just wanted to kind of fill out the rest of the session with some additional information around using runtime and some of those engine workflows associated with engine development. First thing I wanted to highlight here is that product lifecycle for engine. Obviously, the ArcGIS Engine product continues to live on. It's still a viable product actually for use. In some contexts, actually, I just want to highlight here the red line distinguishes a difference between support on Windows and Linux. And so version 10.4.1 was the last version to support, last version of Engine to support use on Linux, right? And so that'll retire in 2022. We'll still continue to support ArcGIS Engine on Windows into the future at this stage. So how do you get started, right? So we've seen a lot of content here about how to get started, start working with runtime, and how to move to runtime from Engine. Probably the best thing to do here, just as a simple place to get started, is to go to the ArcGIS for Developers website, create a free account. You get an Essentials subscription, which is free, which will give you access to our runtime SDKs to download. It'll also give you access to the local server SDK to download that as well, and plug that into the runtime SDKs for .NET, Java, or Qt. And this actually, this item 2 here, this highlights some of an issue, or highlights a a statement that, I can't remember the term, that highlights the statement that Mike made earlier, that this is actually something that works with Runtime SDK for .NET, Java, and Qt. Right, so Runtime SDK for .NET, it's WPF API. For Qt and Java, if it's working on Windows or Linux, you can use the ArcGIS Runtime local server SDK and the workflows that Mike covered here earlier. All of that is available for download on the developer site. There's a great amount of documentation out there on the developer site too. So item 3 here, step 3, is explore that documentation. There's a set of guide doc that walks, and one of the most important parts of that is a guide doc that really highlights the geoprocessing tools that are available. We get about 30% coverage of all the geoprocessing tools that are in desktop today. Right? Now that, at this stage, that we can change that. So if there's additional tools that are necessary that you need, we can light those up. We just need some feedback to indicate what those are. The document that we provide, actually that highlights these tools, is sectioned by license level. So it's important to note which license level those GP tools light up at, because that'll be the licensing that you'll need within runtime to light it up. In order to use our runtime more effectively, step 4 here is really just looking at some of the resources that are available as part of our developer site. We include a set of dev labs, 10 to 15 minutes, kind of getting started with runtime. We almost have 100 of those available now for every runtime SDK, including those supported with a local server. A set of samples and example apps that show you modular functionality as well as finished applications to show some of the common workflows that you can use and build on top of runtime capabilities. With that in mind, a nice important slide here on licensing. So runtime licensing, and how does it factor in to your use or how your migration of engine. So the key thing to keep in mind here is there's 4 different runtime license levels: light, basic, standard, and advanced. There's 2 extensions in green on the bottom here: analysis extension and street map premium. If we cover the license models associated with runtime, there's 2 different license models. One is named user, and the other one is license key or deployment license. Named user is appropriate or is available right now for light and basic levels, runtime license levels. It's not available for entitling other license levels or extensions yet, but will be there at the end of the year. In that case, the license travels with the user, right? So if you've wired up your application to be able to log into a portal, that could be via ArcGIS Online or Enterprise, you can unlock a certain level of runtime functionality. But that's only available at light and basic right now. The license key is available for every level and extension. License key is either one distributed as part of a free license key, which is available as part of the light license. So if you log into the developer site, you create an account, you get a free essentials plan as part of our developer program. You can create a light license key, and you can use that light license key in your application to unlock light functionality. Right? You can deploy this either you're generating revenue or not, doesn't matter. From a runtime perspective, that light license key gives you the ability to deploy that application at no cost. There's a lot of functionality included at light. Generally, it centers around the read-only experience with data, with maps, scenes, layers. Generally, the data is part of the platform. There's some capabilities that are included there for sort of competitive advantage, which includes the ability to geocode, reverse geocode, route. And so that functionality is included as part of light. That's the first and only free level, or level available at no cost. As soon as you move into basic, there's a cost associated with that license. And that usually means that you're going to be editing if you move from light to basic. The difference there is generally editing. You're editing data at some point through runtime. The next level up is standard, and at this point, it's only available through a license key at this stage. And I highlighted here in red some of the capabilities that are basically centered on local server, right? So if you're going to leverage local server to replace some of those workflows that you have in your engine application, it's important to note what's available at different license levels. And so with standard enters the ability to start working with data that's not really part of the ArcGIS platform. It's more of an open standard, but local data that's not part of the platform, right? So shapefiles, geopackages, electronic nautical charts, raster layers. Analysis enters the picture here too. So the visual or exploratory analysis capabilities that you find with line of sight and viewshed right now, but will be enhanced in the future, are available at standard. But the key here is what's in red at the bottom, local server. Obviously, you get the ability to spin up map, feature, and geoprocessing services at the standard level. But there are some limitations. With feature services, you can edit file geodatabases. With GP services, you get a subset of desktop tools at the basic level. And as I mentioned before, these are documented within our our guide docs on the developer site today. As you move to the advanced level, we just enhance that experience, right? So now you can edit enterprise geodatabases with feature services, or you can take advantage of additional tooling with desktop for standard and advanced level tools. The analysis extension is one that applies to local server in the sense that if you decide to enhance your standard or advanced deployment with tools that are in the 3D analyst, spatial analyst, or network analyst toolboxes within desktop, then you need the analysis extension to use those tools. Again, all this is in our documentation. So something to keep in mind here. Actually, there is a set of licensing doc as well as in our documentation that goes into detail about these features and capabilities. This is just to highlight where you need to kind of basically target your efforts with respect to licensing an application that you intend to use for production. And the last slide here is the road ahead. Just some general statements here. I know that Mike covered some road ahead features for the different focal areas that were covered in this section. But this is kind of a general approach to the road ahead with runtime with respect to replacing some of those or supplementing some of those engine workflows in runtime. One is the support for ArcGIS Pro packages. So right now, if you're working with local server and the packaging mechanism that's used for distributing data and capabilities, you're using ArcMap on the desktop to be able to build out those packages. We want to be able to expand that reach and support ArcGIS Pro packages. So you can use Pro and tooling that's available in Pro and package them up in the ArcGIS Pro package format and then be able to deploy and use those with local server. Obviously, local server is really a sort of a small version of ArcGIS server. And so the ArcGIS Enterprise product that includes ArcGIS Server will also be enhanced to support this too. Right? So we're going to match that. Of course, new tools that we need to expose. Here, great to get feedback on what those tools happen to be. Second item here is decoupling versions of runtime and local server. And what this means is that generally when you use local server, you're going to be matching your version of ArcGIS Desktop to your version of ArcGIS Local Server. Right? So the latest version of ArcGIS Local Server, ArcGIS Runtime Local Server, version 100.2, is designed to work with ArcGIS Desktop 10.5.1. Right? And so they're designed to match. And so if you're building out packaging in ArcGIS Desktop or ArcMap 10.5.1, it's designed to work or certified to work with ArcGIS Runtime Local Server 100.2. Right? So there's a match there. What we'd like to do is decouple the API from the local server SDK so that you can use whichever runtime SDK you need with the appropriate local server that matches your desktop version. Right? So conceivably in the future, you could download runtime or the ArcGIS Runtime Local Server 100.2 and use your desktop or ArcMap 10.5.1, and you could download the runtime SDK for .NET 100.4, right, and use the capabilities that are 100.4, but still center or work with local server 100.2 because that matches your desktop release, right, the desktop version that you're using to curate and create packages. So this is an idea. This is a road ahead, something we're considering. Last thing I want to mention here is a migration workshop. So we're working on providing an instructor-led workshop, 2-day workshop, that kind of presents more details around these workflows for getting engine developers into runtime, right, and making them successful. And this is instructor-led initially. What we'd like to do is also record some of this information for wider distribution. The first offering of this as a beta might be as a pre-conference workshop at the user conference this summer. Right, so keep an eye out for that. That's what we'd like to do at this stage. Just it's kind of a trial offering to see if this is something that is worthwhile, something that we need to continue to promote and use. So keep an eye out for the pre-conference workshop at this year's users conference. With that in mind, I'm going to finish up with the obligatory please take our survey slide. So if you have the app and you want to take or provide us with some feedback on this session, that would be great. We'd love to hear it. And with that, we can open it up, I believe, for questions, because I think we've got 1 minute for questions. There we go. So any questions, guys? Yes?
Yeah, the workflow that we want to support is essentially like you could do in an ArcGIS Engine. You could create a file geodatabase from scratch on disk and add content to it. So we want to support that same workflow with the ArcGIS Runtime for mobile geodatabases.
We're targeting this for the end of the year. Yep. The end of the year is update 4, which is 100.4. Targeted, currently scheduled for December, actually. Yes, question?
You were talking about the local server SDK has to match the desktop version installed. Is that just for development, or does that come when my application is running on a machine?
Covers deployment as well. Right. When you deploy a local server, actually the packages that you actually use with that local server deployment, ideally they match. Actually, the versions match so that they correlate with one another. Yep.
And
Right.
what's the lowest version of ArcDesktop support?
Lowest version of ArcGIS Desktop?
Yeah, so we have clients that still run into it.
Gotcha.
But once you deploy your ArcGIS Runtime application, that has no relation to ArcMap or anything that might be installed on the machine. It's
Just for development.
yes, just for development.
The package that was created with Desktop, though,
Yeah.
the version that was used to create that package,
Yeah,
though.
you deploy your geoprocessing packages along with your application onto the deployment machine, but it doesn't matter what else is installed on there. Right? It doesn't interact with ArcMap at all.
Any significant differences between the Arc objects and the runtime, the aspect of the analysis? There are functionality that have been in the Arc objects that are not supported.
So there's two different ways to think about analysis, actually, right? So ArcObjects is actually, it's been developed for, gosh, we're almost going on 20 years, I think, at some point now. So there's a lot of depth and capability that's available within ArcObjects today. So what we're trying to do in runtime at this stage, obviously with runtime, we're targeting more platforms, right? So mobile platforms have entered the arena, and so we're targeting more platforms. The analysis workflows are two different things to think about, right? One is exploratory, which is what we're covering in runtime right now, which is really this visual analysis in a 3D context. It's designed to evaluate or analyze through a visual context. It's not designed to persist that information and then use it in follow-on analytical capabilities. That's something we're looking at doing within runtime in the future. What you have with ArcObjects in general is this persistible result, right, of analysis. And it's a much more broader set of tools, analysis tools that are available. What we'd like to do is start bringing those over to runtime, but we can't bring over all of them, actually, right? So there's some scenarios where if there's tooling or analysis tooling that you need that happens to be available in ArcObjects today, one is provide us with some feedback on what that tooling is so we can evaluate whether or not it's something that we can implement in a native context for runtime. Or two, for the time being, is that tool available, right? Can we access it through local server and use it?
Implementation of something that I can see, I don't know, if I'm using something today and it won't be available in the runtime.
Right. So the analysis capabilities are the native analysis capabilities in runtime today. At this stage, are limited to really place finding or geocoding, network analysis, and some visual analysis. That's the limitations of native implementation, right? So it's fairly restrictive, actually, is what analysis is available natively in runtime. I think what would be key there is that if there's analysis functionality that you use in Engine right now, the first step would be, okay, is that analysis functionality, which generally generates output that's persistible that then you can use in follow-on calculations. You can render in some capacity, right? We'll call it conclusive analysis, right? So analysis that generates a result that then you can utilize and distribute and display beyond just the analysis operation, right? Is evaluate what you're using and see if that's available in local server, right? Is that tool available in local server for you to access today, right? And then the next step would be, well, let's see is this something that we can implement consistently across the board, right? Is it something that we can provide and make available within runtime that we can use not just on Windows and Linux, but also on like iOS and Android devices, right? Is it something we can expose in a consistent, unified manner? So there's a step process there, right? We're entering runtime, native implementation in runtime is entering the analysis sort of world at this point by providing a set of analysis tools that work across every platform consistently, right? And so that takes an effort, right? So we need to evaluate how best to tackle that. The analysis tools that are showing up now, the exploratory analysis tools that are showing up now, is really a cross-platform client effort within Esri. It's not a runtime specific effort. So the exploratory tools that we've introduced here, Line of Sight and ViewShed, also match the exploratory tools we're putting in Pro and exploratory tools we plan to put into JavaScript, right? And so ideally they're on the same path. But that's just a small segment of all the analytical tools that we could potentially add, right? So we're on a long road. We're just starting out at this point. Yep. Hopefully that helps. Any other questions, guys? Great. Thanks for joining us. Hopefully you stick around for the closing session and get some good lunch. And otherwise, have safe travel. Cool. Thank you. Thanks for joining us, guys.